I'm standing here at the edge of the Charles Darwin University in Darwin. Just about 100 meters down this way is the sculpture of Darwin's microscope. And a couple of 100 meters off this way is where Stephen Garnett talked about the bowerbirds. A little bit over here is where we saw the green ants and the termite nests. So there's quite a bit of wildlife activity. In addition to those things, we have a lot of bird life, including orange-footed scrubfowl, frill-neck lizards, other dragon lizards, goannas. There's at least 4 species of pythons on campus, and about a dozen frog species, and occasionally there's a dingo walks through campus. But probably the most remarkable feature of this campus is one that we haven't shown you yet, and it's right here in front of me now. We have a forest. It's a mangrove forest that lines the banks of Rapid Creek. The creek empties into the sea about 500 meters off to my right, but before it does, it snakes through along this area in front of me. Because the tides are so extreme in Darwin Harbor, up to about 7 meters sometimes of the year, at high tide the water spreads out over a wide area in front of me. So it's a reasonably good sized area of mangroves that you can see from this Google Earth view. The tides come in and out twice a day, so this area is alternately flooded and drained on a regular basis. That means there's a transfer of nutrients between the marine and terrestrial habitats. This area is teeming with life, including a variety of crabs. Their holes are everywhere, gastropods and other mollusks, and a wide range of marine worms. At high tide, small fish move in, and occasionally a crocodile moves into Rapid Creek. So all of these are animals that you might associate with mangroves, but there are a couple of species that you might not associate with mangroves that are living here. It's been said that if everything in Australia disappeared, all the land and all the plants and animals, other than the ants, if everything just disappeared, you'd still be able to see an outline of Australia and all of its features because there's so many ants here. Not only are there a lot of individual ants, there are more species of ants here than there are anywhere else in the world. The richest diversity of ants is about 1,500 or 2,000 kilometers to our south in central deserts of Australia. But up here in the tropical north, there's still a lot of ants. We have more species of ants than most places. And 2 of those species are mangrove specialists. Now you might not think that an area that's inundated by seawater a couple of times a day would be a very hospitable habitat for an ant. And in fact, these ants have to have some very unique evolutionary adaptations to survive in this environment. One of the species nests here in the mud, and so their nests are inundated by seawater at most high tides. About 60% of the high tides, their nests are inundated. And they may stay underwater for up to 3.5 hours. So that's a very unusual sort of a set of circumstances because there's water in the mud. There are very few places for them to breathe. So this is the second species that nests in the trees. And you might think that that would be how they avoided the intrusion of seawater a couple of times a day at high tides. But in fact, because the tides are so high here, up to 7 meters, this area is often regularly inundated, and sometimes for up to 3 hours. So these guys seal themselves into their nests by using the head of one of the workers, and they'll sit there for up to 3 hours underwater. The nests of both of these species experience long periods of inundation, so let's look at the adaptations that allow these ants to survive those conditions. Let's start with the species that nests in the mud, and it's in the genus Polyrhacus. The nests are frequently inundated for up to 3.5 hours. Parts of the nest flood, but some galleries trap pockets of air which allows the ants to survive. However, the oxygen is used up in those galleries pretty quickly, and carbon dioxide levels rise. Carbon dioxide is an anesthetic for most insects, and if they're left in high levels of of carbon dioxide for long periods, they'll eventually die. In other ants, a nest with 3% carbon dioxide is considered very high concentration of carbon dioxide. That's about 100 times more carbon dioxide than is in fresh air. But during and after inundation, we measured carbon dioxide values as high as 11% in the mud nests of the Polyrhacus ants. Some of this is due to the respiration of the ants, about 10 or 15% of it, but mostly it's due to the microbes in the mud. So the Polyrhacus have both behavioral adaptations, that's related to their activities and the nest construction, and also physiological adaptations related to their ability to tolerate high levels of carbon dioxide. The second species is in the genus Camponotus, and they nest in the trees of one species of mangrove. However, these trees are inundated, so they also experience periods where they're underwater. Inundation can last for up to 3 hours, and during the inundation, a specialized worker or soldier ant plugs the nest opening with her head. This prevents flooding, but it also excludes fresh air. So during the period of inundation, carbon dioxide inside the nest, which is really just a hollowed out twig and quite small, rises to 30%, an extremely high level of carbon dioxide, and the oxygen level drops to about 1%. The respiration rate of the ants drops very quickly and drastically to less than 2% of normal respiration rates. They enter a state of torpor. So the ants survive by using anaerobic respiration. This is the first social insect that's been shown to use anaerobic respiration. So the Camponotus ant exhibits behavioral adaptations related to the construction of the nests and the use of the head of a specialized worker to plug up the opening of the nest. And they also exhibit extreme physiological adaptations to the low oxygen and high carbon dioxide environment inside their nests during the long periods of inundation. So both of these species exhibit evolutionary adaptations that allow them to survive in an environment that you don't normally associate with ants.